Okay, so we were on the eighth sum of problem set. Did you complete this sum? Could you prove left hand side equal to right hand side? What?
No, I did not do this.
Did not do? Why? What
This
happened?
is not for the homework, right? You were given the homework 2, 3, and 4.
I think that you sent me. I think so.
Yeah, I did that and I sent it to you. 8, I don't remember you telling me. Or maybe you had told me. I forgot.
Okay. In that sum, do you have you solved it in pencil, right? Is that book in front of you? So the sine theta sum. Second one. Sine
Question 2.
theta. Yes, sine theta 11 upon 61. Okay, everything is correct. Then up to the point where you take square root on both the sides. Okay, so you have written, okay, just come to the point where you took square root on both the sides. So you have written cos theta is equal to under root of 3600 upon 3721. Okay, and then you took square root of 3600 and you took square root of 3721. Now you have written square root of 3600, you have written it as 600, and square root of 3721 is 61. So square root of 3721 61 is correct, but square root of 3600 is not 600. Can you spot your mistake?
Oh, I don't know. I mean, 36 ka, it is 6 and then 2
Six.
zeros, so you'll add.
But you're missing the square root. You're missing the square root. See, it is in the square root, right? Square root of 3600. So what you can do to break it down is, or you can use the prime factor method, but that will be too lengthy because this is 3600. So the shorter way will be 3600. You can write it as 36 into 100. What you did is correct, this, but just one part of it is wrong. So here you can then separate the root sign. So root of 36 into root of 100. So what is root of 36?
6.
And root of 100?
10.
10. And 6 into 10?
60.
60. So what is square root of 3600?
But won't we take it as 36 ka square? 36 is the root of 6 and then 2 zeros.
No, that is right what you're saying, but it is inside the root. The whole thing is inside the square root.
Inside the root only. Inside the root, we can't do that.
No, you cannot do that. See, by meaning of square root, so suppose I say square root 4. Okay, what is square root of 4? What is square root of 4?
Sorry, 2.
2. 2. And when you square 2, what will you get?
4.
So you should get this number back. When you square the answer, you should get the number back. Yes, I hope you're understanding this.
Yes.
So same thing, suppose if I say square root of 9, and you know square root of 9 is 3.
3.
And
so 3 square is also 9.
Yes, 3 square is 9. So you should get it back. Now coming back to this example. Square root 3600. Suppose you said 600. Now when you square this, you should get this back. So can you tell me what is the square of 600? square of 600. 600 means 600. Square of 600 means 600 into 600.
That is 3 lakh.
Yes. So yes. So see, it is not matching.
3 lakh 60,000.
Yes. So it's not matching. You can see, but I need 3600. So obviously 10 is more.
Okay, 60.
So that's why 60. And now when you take the square root of 60.
So 1 second. So when you take the square root of 360, then what will be the answer?
Square root of 360. This we can try by prime factor, or we can write this as 36 into 10, because 36 into 10 is 360. Separate the root. So you'll have 36 into root of 10. And you know square root of 36 is 6. And this root 10 you can keep as it is. So square root of 360 is 6 root 10.
Okay.
Clear? Okay. So you have to do your correction there. Cos theta is equal to 60 upon 61. Yes. Correct. Now the next one, I think is the second tan theta one, I guess.
Tan theta is equal to 2.
Yes, tan theta is equal to 2. Find the values for the trigonometric ratios. Okay, now here also there is a small mistake. Let's see, look at the beginning, right at the beginning. So you had started with tan theta is equal to 2. Yes, then you have used the identity tan square theta plus 1 is equal to sec square theta. Then you substituted the value of value of tan, that is tan square plus 1 is equal to sec square theta. So this will become 4 plus 1 is equal to sec square theta. So that is 5 is equal to sec square theta. Now, one thing, carefully note and look at this sum. Sec square theta is 5. Okay, you have to find out sec theta. Okay, sec square theta is 5. So what will be sec theta? To remove, what should you do? Yes, root of 5. So that you will get by taking square root both sides. So here you have done the mistake. You have just taken 5.
When will we get to know the result of this? Because like last time it's not being displayed.
So sec theta is equal to 5. And now from the sec theta, you can find out what is cos theta. So you know cos is reciprocal of sec. So this will be 1 upon
root 5.
root of 5. Correct. Can you do the correction?
Yes, good.
So we found out sec. We have to find out all trigonometric ratios, sine, cos, tan, sec, cosec, and
Yes,
cos.
yes, I've found all.
But now since sec is wrong, cos also is wrong. Now since cos is wrong, sine also is wrong. Since sine is wrong, cosec will also be wrong. And now since cosec is wrong, cot will also be wrong.
So I should do it again.
Yes.
So
No, right now. Not for homework, right now. So first do the correction of sec and cos. And once you finish with that, we'll go for the next thing.
So then in the next thing will become 1 upon root 5. So root 5 will become what?
No, next you have to find out sine theta. Sine theta.
Yeah.
So for sine theta, you will have to use the first identity. Sine square theta plus cos square theta is equal
Are you
to...
referring to the picture I've sent you? I've done it in the same.
Yes, I'm looking to that picture only.
Okay, sir.
But you'll have to do the calculation all over again.
Yes, so it will become 1 minus 1 upon root 5 whole bracket square.
Correct.
So that is what I was asking, what will happen after that?
You'll have to take the square. 1 minus, first take the square. So I think you're talking about this 1 minus 1 upon root 5, the whole square, correct? Now, after this, you will have to take the square. So what is square of 1? Square of 1 will be 1 itself. And what is square of root of 5?
Can we not separate, can we not cancel root and square?
Yes, you can. You can. So it will become 5. And then you do the cross multiplication. 5 minus 1 upon 5, which is 4 upon 5. And that is how you get your sine theta to be...
Wait, what?
Cross multiplication.
1 upon 5, right?
Sorry?
1 upon 5, right? So it will become
1.
5 minus 1 upon 5.
Correct. And how much is 5 minus 1? Yes, 5 minus 1?
4. So 4
4.
upon 5.
4 upon 5. And that is how you get sine theta 4 upon 5. So did you do the correction here?
Yes, and then cosec will be 5 upon 4.
Yeah, correct. 5 upon 4. So, but make sure you write the, you have written. So cosec, then by this, since cosec and sine are reciprocal, cosec theta will be 5 upon 4. And now use the third identity to find out cot.
Why? You can directly find out that cot theta is equal to cos 1 upon cos.
No. Cot and cos are not reciprocal of each other. Cot and tan
are.
Tan. You
But
have
in the
written...
sum only they have given tan. So then we can write tan theta equals to 1 upon
Yes. But corrected formula, that formula is wrong. You should have written cot theta is equal to 1 upon tan theta.
So it equals to
1 upon
2.
2. Correct. Show me your calculations.
1 upon 2.
Yes. Correct that formula first. Yeah. Correct the formula, okay?
I have written all of those together in the final as the final answer. So there also I'll have to correct.
Yes. Yes. Can you move down? Okay. Move to the other side. Yeah. Yes. Move to downwards. Yeah. Okay. Good. That correct. And now I think one more sum was there. The fourth one. Yeah. I'll just see the fourth one. Yes, I have the photo. I'll just check it from the photo. Yes, fourth one is perfect. So we'll continue with the proofs. We were
Also,
on
the
the
school did not go to the first chapter. They said that they are not going to teach the first chapter, and they went to the third chapter, circle.
circles. Okay. Circles is a really lengthy one, almost a month it would take to finish circles. So I was thinking to keep circles for last. It's very, very
Yeah,
lengthy.
we can do
Yeah.
that also.
Okay, so we'll come to the eighth proof. Okay, did you
1 second. We have to do 8, 9, 10, and 11, right?
8, 9, and 10? There's no 11 for me.
10.
10.
We are going to be doing the word problems also.
For word problems, we need little bit basics. So we'll do the basics. Word problems is last.
That means we're going to do word problem.
Yeah. We'll be doing word problems.
Okay,
Angle
because
of
the school did not do it.
yeah,
They
you told.
directly went to circle.
Yeah, I think you told me. But I think it's better if we do it. We have time for it. Okay, so I think the previous exercise, 6.2 is entire word problems. Yes, so I will start with this. And this is easy. We need a little bit basics for it. So I'll do that basics today. And I think most probably in the next 2 classes, word problems should get over. Okay, so before that, we'll do the 8th proof. So the 8th proof is tan theta upon sec theta plus 1 is equal to sec theta minus 1 upon tan theta. Now, note one thing, this is the original question. You can rearrange your original questions. You can rearrange the original question and change your LHS and RHS. Okay, just by rearranging the original
How to
question.
know that if whether it is an original question or already arranged?
I didn't understand. Your question is how to?
You said that this is an original question, so I asked you that how to find out whether they are original questions or the question is already rearranged.
No. Whatever is written in the paper, that is the original thing. Whatever you are doing changes, that will be the rearranged one. Okay, so now this is written. This is the question that is given to me. I will rearrange it. I will change it according to my convenience. And in that way, the LHS and RHS also will get changed when you're doing the proof, when you're starting with the proof. See here, this is your LHS original one, that is as it is mentioned in the question. And this is your RHS. Now I will do rearranging, and that rearranging is by cross multiplying. So I'll just write here. There is no need to write cross multiplication, but I'm just for understanding sake. So by cross multiplication. So first you multiply these two. So tan theta into tan theta will give you tan square theta is equal to, then you multiply these two. Sec theta minus 1 into sec theta plus 1. Now note one thing, there is an equal to sign. That is why there is no need to multiply the denominator. Okay, up to here, did you understand? Okay, now if you look at now this is my new LHS and this is my new RHS. Okay, tan square theta is my new LHS and sec theta minus 1 into sec theta plus 1 is my new RHS. Now, what I will do in this sum is I will take the RHS and I will try to prove
1 second.
the LHS. Yes.
When you did that, why didn't you write tan theta into tan theta? Why did you write tan square theta?
I multiplied
Because
it
if you
directly.
write No,
And
because then if you do tan theta into tan theta, then you can take tan theta on one, like you can take one tan theta on that side. And so then
but
you can say sec
that
theta plus 1. You can
that
rearrange
will
it.
make us some lengthy if I keep one tan theta here and take it on the other side. So it will just make some
No,
little
because
bit
then
lengthy.
if you square sec theta plus 1, then you will get sec square theta plus 1.
Uh,
So then you can
but
use
to note
that
one thing,
formula.
sec theta plus, there is no square here. On sec theta, there is no square.
Yeah, so
And
you can square it.
so yes. So if you go to square it, now you'll have to square this entire term because it is together. Sec theta plus 1 is together. So if you're squaring it, this entire thing has to be squared then. And then that will create a problem.
Okay.
Are you getting it?
Yeah.
Okay. So that's why at this point only we'll say that this is my LHS and this is my RHS. Now take your RHS. You take your RHS, and from RHS we'll try to bring our LHS. So my RHS is sec theta minus 1 into sec theta plus 1. From here, I will try to make this equal to my LHS. That is, I'll try to bring tan square theta. Now, if you see, this is of the form A minus B, A plus B. Okay, this is of the form A minus B, A plus B. So how will this become? Can you tell me? Yes. A minus B, A plus B. This is
A
equal
square
to
minus B square.
A square minus B square. Correct. So this is also same. A minus.
Square. Yeah, sec square theta minus
Yes.
1 square.
Yes. Sec square theta minus 1 square. So this will become sec square theta.
So wait, aren't you doing the same thing that I
Same.
said? But you are just doing it in a different way.
Yeah. But you
This
said.
will take less time.
Yeah, yes. So now here we can use the second identity. 1 plus tan square theta is equal to sec square theta. And if you take 1 on the other side, you will get tan square theta is equal to sec square theta minus 1. So you know what is sec square theta minus 1. So by this formula, sec square theta minus 1 is equal to tan square theta. And this is equal to my LHS. So from here, you can say that RHS is equal to LHS, hence proof. Did you understand this question? The solution? Yes?
Yes.
Okay. Now,
Simplest.
yes. Now write it down.
Also, Renuka Miss has kept what do you call, a test this Sunday, and I have a Sanskrit test every Saturday. So Saturday, Sunday are totally booked.
Okay, it's okay. We'll keep us next week.
No, every Saturday Sanskrit class is going to be Sanskrit class also and test also.
Every Saturday.
So every Saturday.
Okay, then we'll keep it on Tuesdays.
Which is there on Tuesday?
We'll decide. We'll decide that. We'll decide.
Okay.
But I'll let you know way in advance so that you can prepare.
Next Tuesday, right? You said.
Today's Tuesday, no? Let's see. On Friday. We'll decide by how much we finish. On Friday, we'll decide.
So when are you going to keep it? Did you say you will? Okay, I did not understand what you said.
No. You said every Saturday you will be having a test, right? So then
Yeah.
I will not keep on Sundays any test. I will, whenever I want to keep a test, I'll keep it on a Tuesday. Okay, is that fine? Every Tuesdays. So you will have 2 days to prepare. Sunday, Monday, you will have.
Just 2 days?
Why is it less? 20 marks test, I think 2 days is enough.
So, oh, so like only 2 days or what?
No. I'll tell you the test way. When I'm taking it, I'll tell you way in advance. You'll have enough time to prepare. At least 5 days in advance, I'll tell you. Don't worry about that.
Yeah, okay.
Yeah.
Okay. You stop screen share.
Yes. Perfect. Yeah, I saw it. So now let's move on to the ninth sum.
Can you show me the 10th sum? Just 1 minute. Can you show me the 10th sum?
This one?
In which sum is 26 and 22 the denominator in any sum?
26 and 22. No, nothing in the problem set. Why? There's some problem in any sum?
Mario is doing nice myself.
Because our teacher has taught us in a different way. I mean, one
Just
sum,
put
like
oil.
the way in which normally we do, she's not told us to do. Should I show you?
Yes.
We'll have to stop screen sharing because I have a photo. I don't know if it's written.
So what will, it's in your computer? It's on your laptop?
Yes, yes.
Okay, wait. Yeah.
Which sum is this?
Can you zoom? Just zoom in a little bit. Yeah.
This sum, she's taken A and B instead of anything else, and she has done it by the trigonometric identity.
Okay, this is an example sum from your textbook.
Yeah, so she's taken 2A and 2B.
Yeah, yeah. That is a question. That is a question where you can see 2A and 2B this. It's a question. 1 second. Huh?
1 second. See, I think it's on page 131. That one she's done it. So she's done it like this, and so she's told us that whenever like these sums come, you no need to write the trigonometric identity over there. So, but still she has written it. So you don't need to write the trigonometric identities or any formulas. You can just simply do it because you're taking A and B.
Hmm.
What
It's
she told us.
eliminating theta. Does the sum starts here and ends here?
Um, no. I think there is something before this.
Okay. Can you show me the question? Do you have the
The
question with you?
question is, yeah, just one second. One second. Here is the question. The entire sum, I think, is here. She's
Yeah,
also done it in the same way, but she's just told us that we don't need to we don't need to use like even if we use we don't need to write because we're using A, B, X, and Y. So that is
yeah. I understood. This sum is called as eliminating theta. So I did not do this sum because it is not there anywhere in the exercise. So it's like this I wanted to do last. Because it's just this one example sum, and this example sum is nowhere in the exercise, nor even in the this type of sum is nowhere in the exercise nor in the problem set. But we'll do it. We'll do it at last.
okay. Fine.
It's basically eliminating theta. That means you have to remove the theta from your question.
Yeah.
Okay, so we had, okay, we were supposed to do the ninth one. So let's do the ninth. Now the ninth one is also very easy, although it looks difficult. It's just, you will get the answer in 3 to 4 steps. So the LHS here is tan cube theta minus 1 upon tan theta minus 1 is equal to sec square theta plus tan theta. So we have to prove LHS is equal to the sec square theta plus tan theta. So let's start with the LHS. So LHS is equal to tan cube theta minus 1 upon tan theta minus 1. Now, before we start with this sum, one formula. Do you know the formula of a cube minus b cube? The expression a cube minus b cube. You must have done this in
E plus B plus C. Oh, sorry. No, I don't remember this.
expansion. A cube minus b cube. The formula is, I'll give you the formula, a minus b into a square plus ab plus b square. This is the expansion formula of a cube minus b cube. Did you recollect?
No, I didn't.
This was a very famous chapter in 8th standard. You have an entire chapter on just this formula, a cube minus b cube, a minus b, a square plus ab plus b square. It's okay, you can do it now, remember it now. So a cube minus b cube is a minus b, a square plus ab plus b square. Similarly, we have a cube plus b cube also. So that we'll do in the next time. So have you understood? Write down this formula. Write down this formula first.
Just 1 minute.
Yes.
How many times do I have to write this?
Formula? No, formula. I just
Yeah.
wanted to make a note of it
Oh,
for
okay.
now. Just make a note of it. Because we are going to use this formula in the sum. Done? Okay, now coming back to this sum. Now, look at the numerator of the sum. In the numerator, you have tan cube minus 1. Now, I want to use this formula in the numerator. But to use this formula, it has to be of the form a cube minus b cube. So what we'll do is, this tan cube theta, will write it as it is. And this 1, we can write it as 1 cube. Because 1 cube is 1 itself.
Tan cube theta.
Yes, tan cube theta. Tan cube theta minus 1 cube. And the denominator as it is. Tan theta minus 1.
1 cube.
What is 1 cube?
1. But then
1.
you can't just do it like that, right?
No. We can do it. I'm just replacing.
So what if it was 3? Then how would you take it?
No. Then you couldn't have done it. You couldn't have done it. If it was 3, you couldn't have done it because 3 cube is not 3. Is
there any formula for a cube minus b?
A cube minus, no.
Okay, so then you will have to make it cube.
Yes, you have to make it cube. So just because it is 1, it is easy. If there would be any other number other than 1, then it would not be possible to do this.
This only works for 1 then?
Yes, this only works for 1, correct. Only for 1. It will not work for 2, 3, and so on. Now here in the numerator, use the formula a cube minus b cube. So this is a, and this is A is tan theta and B is 1. So let's do the expansion. So by the formula, it is A minus B. So tan theta minus 1 into A square. So tan square theta plus A into B. So A is tan theta, so tan theta into B, B is 1, plus B square.
1 cube. 1 square, sorry.
1 square, that is 1 itself. So I'll just write 1. Upon tan theta minus 1. Can you see something getting cancelled from the numerator and the denominator?
Tan theta minus 1.
Yes, tan theta minus 1.
And also if 1 is in the outside the bracket and no,
Yeah, this two will get multiplied. Okay, so that is just tan theta itself. So you have tan square theta plus tan theta plus 1. Is this clear?
So, how? 1 plus 1, right?
No. Multiplication first, Bodmer's rule.
Oh yeah, okay.
Multiplication first. So that's why you cannot add this. Okay, so tan theta into
But
1.
you had said that theta will always remain like theta, so you cannot separate theta and 1.
But we are multiplying tan theta with 1.
Okay.
Not theta, it is tan theta with 1. Oh, so we are left with tan square theta plus tan theta plus 1. Now just rearranging, I'll just write this 1 first. So 1 plus tan square theta plus tan theta. Okay, this rearranging is done and I've written that 1 first. Now if you see, look at this. This forms the second identity, 1 plus tan square theta. So what is the formula? 1 plus tan square theta is equal to?
Sec square theta.
Yes, sec square theta. So you can replace it. So this becomes sec square theta plus tan theta. And now if you see, this is equal to your RHS. Sec square theta plus tan theta. So we can stop here. And finally, you can say LHS equal to RHS. Hence proved. Did you understand the sum? Is the sum clear? Any doubts? Okay, now step by step, write it down. And if you have any doubts, you can ask.
Yeah, I'll write it down.
Okay, understand all the steps and write it down. And if you have any problem, any doubt, you can ask me.
I just have a question. If we would have squared tan, the RHS sec square theta plus tan square theta, if we would have squared it, then it would have been easier to find LHS.
If you would have wanted to square tan, now there is an This is the entire term on the RHS, sec square theta plus tan theta. So if you cannot just square one term, you'll have to square the entire thing. So it would be like sec square theta plus tan theta whole bracket square. And then that would get more complicated. Understood?
Yeah.
Since there is an addition sign and there is more terms with it, that is the reason. Yes, good.
When I show it to you, you can see it like, you can read it like that only, right?
Yes, yes, I can see it full screen.
No, like it does not get mirrored, right?
No, it doesn't.
Okay.
Okay, so we have one last sum remaining proof. Then after that, and then in the next class, we'll start with the problem sums. Problem sums are based on
How
angle
much
of.
time is this going to take?
This may take time. 1 second, let me see. I'll give you a hint. You can do it yourself for work. We'll discuss in the next class. You have a class immediately?
Yeah.
Okay, we'll stop then here.
I have a class at 5:15, not immediately.
Okay, this will take more than 15 minutes. It's okay. So,
So if you want to give me the hint, and then I can do it for the homework.
Yes, I'll give you a hint. Start with the right hand side and take conjugate of the denominator. Okay, can you just look at the screen for a minute? So you see the denominator. Start with your left hand side and take this term and do rationalization. So when you're doing rationalization, you will multiply it with this term and just make this positive.
Again, can you tell me from the beginning?
What?
Can you tell me all the clues from the beginning?
you try the rationalization first. Try the rationalization. After that, then you'll have two brackets. First and the second
No,
bracket.
like what? Can you repeat from the beginning?
Okay. I said rationalize the denominator. Okay, so you know when we rationalize the denominator, you
That is
take
the first step.
yes, first step.
Okay,
Rationalize the
then
denominator.
what did you say? Take conjugate of?
When you're rationalizing, you have to take the conjugate, that is opposite sign you have to take. So that means, see, this will be one term. Just look at the screen. This will be one term and this will be the other term. So when you're taking the conjugate, you'll have to change this sign. So this will become plus.
1 plus cos theta
Yes.
plus cos
Plus 1.
sin theta plus cos. So then if I have to take the thing, then it will become into, right?
Yes, multiplied by, yeah.
So so LHS into LHS into sin theta plus cos theta plus 1.
Yes, and upon also, same thing.
Sin theta plus cos theta plus 1.
Correct?
Okay,
now
fine, got it.
after this, you just have to do bracket to bracket multiplication.
Yeah,
and
then, yeah.
try
Cross multiplication or not?
bracket to, yes. Not cross, there is a multiplication sign, na? And there are two fractions. So numerator with numerator, denominator with denominator.
Okay.
Okay, try it up to here. Once you finish this step, you will get to know automatically what to do next.
Okay,
Fine? Okay.
Fine.
So try this. See you on Thursday.
Okay. Thank you.
Bye. Welcome. Yes.